Welcome to the first unit of Chapter 10. We're going to be probably doing quadratics, if you can kind of look at that right here, quadratics the rest of the school year. So what we learned today in this lesson, we're going to be carrying till June. Okay, so this is pretty big because we're going to have to remember it all the way towards the end of May. Some of you may already know what quadratics are. Remember we talked about vocabulary words earlier this year where quadratic kind of meant a degree or power of 2. We're going to specifically be focusing on equations that have this x squared in them. And some of you might even remember what the graph of a quadratic function looks like. And I tried to put some pictures of common things that we might already know, like the Golden Gate Bridge and the Eiffel Tower, to show how quadratic graphs normally come into play in real life. So if you take a look at the awful pen motion right here, but take a look at the shape that the Golden Gate Bridge has right here. It kind of makes this U shape going on. Okay, we're going to look at that shape today. It's actually called a parabola, but we're going to see some U-shaped graphs. Also, if you take a look at the Eiffel Tower, this time the U shape is kind of upside down, but that doesn't really change anything, okay? It just means that the parabola might be negative, okay? Kind of flips it over. So we can have U shapes that go up, or we can have U shapes that go down. All right, so for us to really focus on these quadratics we're going to be talking about the rest of the school year, we're going to need to really know some essential vocabulary in order for us to understand some of these things. And I just kind of already briefly talked about the first two. A quadratic function always has a highest degree of 2. So that means we can have something like x squared plus 3x minus 4. Maybe we can have something like 2x squared minus x plus 5. Or maybe we'll throw a fraction in there, 1/4 x minus 1. Okay, all of these would be considered quadratic functions because the highest degree in all of them is the power of 2. So all of these are quadratic functions. The graph of these quadratic functions over here is always going to look like a parabola, and more specifically, some of us like to remember that as a U shape. So sometimes the graphs, just like the Golden Gate Bridge or the Eiffel Tower, sometimes the U shape might go up, other times the U shape might go down. Okay, so whenever you see this power of 2, okay, remember that's the highest power, your graph is always going to look like a parabola. It's going to be a U. Either it's going up or it's going down. Something going on within this parabola, okay, within this U-shaped graph, either going up or going down, is something called the vertex. And we might remember the vertex when way back at the beginning of the year we were talking about absolute values. Okay, those were the V-shaped graphs, but this time quadratic functions have U-shapes. So just like the absolute value graphs had a vertex, so do these quadratic functions. And the vertex is the highest or lowest point on the parabola. So if we have a U-shaped parabola that opens up, the vertex in this case would be the lowest point, kind of the point at the bottom. But on the other side, if we have a parabola that's going down, the vertex would in this case be a highest point, the one at the very tippy top. So maybe we'll label these as the vertices, okay, plural of vertex. Lastly, we're going to talk about the axis of symmetry, and the axis of symmetry is very much related to the vertex. Okay, it's the x value of the vertex. So if we look at maybe a U shape that goes up or even a U shape that goes down, okay, we said this would be the vertex and then this would be the vertex. The axis of symmetry is the x value of the vertex that folds the parabola in half. So if you can imagine maybe folding the parabola right down this dotted line, okay, folding the right-hand side over to the left, all the different points, the two sides of the parabola would match up. Same thing going here, even if the parabola is upside down. If we were to take the right-hand side and fold it over the axis of symmetry, over this dotted line that goes through the vertex, the two sides would match up. You can almost think about it like your face. Okay, maybe I'll draw a little face right here. Okay. Pretend like your nose is the vertex. If we were to draw a dotted line, okay, right through your nose, and you were to fold your right hand side of your face over to the left, your right eye would match up on your left eye, and the right side of your mouth would match up on the left side of your mouth, and maybe your right ear would match up with your left ear. Kind of looks like a monkey, but not much of an artist, I'd say. Right, so axis of symmetry goes right through the vertex, and we're specifically looking at the x value. All right, so now that we have kind of a brief understanding of the different vocabulary that we're going to be using, we are going to look at 3 specific ways that quadratic equations might be written. Okay, and the first way we're going to talk about is standard form, and this is the one that I think most of us are used to seeing the quadratic equations written. Okay, it's ax squared plus bx plus c. Everything is kind of nice and neat, standard form. The biggest degree comes first, then the next biggest, and then your constant number. So this is what most of us, I think, are really going to like these equations to look like. Some different key points to this type of equation when it looks in standard form. Our parabola, remember that's our U-shaped graph, it opens up, meaning it looks something like this. Okay, it opens up if a, okay, the number in front of the x squared, that a value, is positive. So like 1, 2, maybe 3.5. If a is positive, our parabola is going to open upward. Now that means, okay, if we think about the vertex, somewhere right there, the highest or lowest point, since our parabola opens up, that means our vertex in this case is a low point. More specifically, it's the lowest point, so we can classify that as the minimum. Okay, this is the absolute minimum, absolute lowest point that this graph is going to have. Okay, so that's if a is positive. On the other side, we could say that the parabola opens down, so maybe it looks something like that. If a, in this case, is negative. So if it's -1 or -3, maybe -9.5, something like that, okay, the negative just flips it upside down. Now, this also changes the position of the vertex. Instead of being a low point, now our vertex is a high point, the highest actually, so we can label it as a max. Okay, this is the max, this is the highest that your parabola, your graph, is ever going to go. All right, some other ones, let's see. The parabola, this U shape, is wide if your a value, remember we're always going back to the number out front, your a value is less than 1. Meaning if we have 1/4 x squared, blah, 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 blah. Okay, 1/4 x squared, your parabola is going to be really, really wide. So it's almost going to look something like this, almost like a bowl or maybe a smiley face. Okay, it's really, really wide. On the other hand, maybe our parabola is narrow, like really skinny, if a is bigger than 1. So maybe we have something like 3x squared dot 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 dot. We don't really know what this other stuff is, but as long as this a value, the number in front of the x squared, is bigger than 1, your U shape is going to be very skinny. So it's going to look maybe something like this. Okay, we're not exactly how skinny it is, but we know it's going to be fairly skinny. Okay. All right, so I specifically put the last 2 in this little box because these are probably the most important 2 that we're actually going to need today. Okay, so the axis of symmetry, remember that's the dotted line that goes right through the vertex? Okay, the axis of symmetry is the vertical line x equals, we're going to say the opposite of b over 2a. Okay, now remember vertical line, okay, just like what we had here, dot, dot, dot. Remember, if we go back to our vocab, the axis of symmetry is the x value. Okay, so that's why it says x equals. And we're specifically going to use this little formula, the opposite of b over 2a, to help us find the x value of the vertex. So b and a, okay, always going back to this little standard form up here, b would be the number in front of the x, and then again a is the number in front of the x squared, the same a we've been talking about for these 4 other characteristics. Okay, so we kind of used b and a in the little formula to find the axis of symmetry, but that means that the one we really haven't used yet, this c, is the y-intercept. And you can almost think about, I mean, we're really familiar with y equals mx plus b. we know in this case that the b is the y-intercept. Okay, this is the number kind of all by itself. It's all by itself on the end. That's the same thing going on here. Notice how in this case, even though they're not the same letter, okay, this c is the last number all by itself on the end. So we can kind of make the connection here, but just be careful that you don't get the letters confused. Okay, we're specifically talking about ax squared plus bx plus c in this case, and not y equals mx plus b, because this mx plus b is a line, whereas this ax squared plus bx plus c is a parabola. So the c in this case is the y-intercept. All right, so we're done talking about standard form. Remember, I told you we're going to have 3 different forms. The next one we're going to talk about is vertex form, and notice how this one looks a little bit different than the other one we just did. Okay, we still have the same a value. Okay, if we go back over here, we still have the same a value, but we don't have the b or the c stuff that was going on before. This time our equation looks a little bit different. We have h's and k's. Okay, now just like the other one, the blue box right here is probably the most important information that we're going to have to use today. And what's nice about vertex form is that, I mean, since it's called vertex form, we should be able to probably find the vertex just by looking at this equation. And that's exactly what we can do. The vertex is as simple as identifying what is the h number and what is the k number. So our h would be our x value, and the k is going to be our y value. Now we're eventually going to look at an example over here to kind of make sense of this, but if you can figure out what this h number is and what this k number is, you already know what the vertex is. That's why it's called vertex form. You can find the vertex. Now, just like before, we said the axis of symmetry was the x value of the vertex, and if this is our vertex, hk, the x value in this case is h, because that's the letter, I guess, in the position where x normally is. So the axis of symmetry would just be this h value. What's nice about this is that all of the characteristics we said about the a term, okay, if I go back over here, all 4 of these different things that we talked about, they apply here as well. So if your a is positive, it opens up. If your a is negative, it opens down. If your a is bigger than 1, it's kind of narrow. If your a is smaller than 1, it gets really wide. Okay, all those different characteristics apply here as well. You just got to look at the same a. Let's take a look at an example just to kind of make sense of this. If we try to find the vertex, okay, we need to identify what is the h value, what is the k value. So maybe I'll label vertex form above this, just so we can start to make some connections here. All right, so the vertex, according to vertex form, says x minus h. And according to this, I want to figure out what is h. So if x minus h is in the general form, let's take a look at our example. We have x minus 2. So the x's match, the negative sign matches, so that must mean that the h is 2. Now over here, the plus sign matches, which means the k must match. The k is 4. Okay, so I just found what my h value was, found what my k value was, and there's my vertex. Okay, I know that this is the highest or the lowest point of my graph. If I wanted to find the axis of symmetry, okay, it's always the x value of the vertex, and if this point is my vertex, the x value would be 2. Okay, so that's not too bad. Maybe we'll label this axis of symmetry. We'll just abbreviate it AOS. Now let's talk about this a term. Okay, we already found h, we already found k. A is always the number out front, so a in this case is 2. Since this is a positive number, okay, we can assume that our parabola opens up. Okay, it looks something like that. And if it opens up, that means our vertex is a minimum. Okay, it's a low point. This 2, 4 is going to be a low point. And also, since a equals 2 is bigger than 0, we can say that we are going to have a narrow graph. Okay, it's going to be very, very thin. All right, so that's vertex form. All right, last but not least, we have intercept form, and just like vertex form, we could probably find the vertex. If this is called intercept form, we're going to be able to find some intercepts. So in this case, and this is what is really nice kind of about math, is because everything is related. I think that we're going to like this one the most, probably, because it's something that we've already kind of done. The intercepts, we said, are always, those zeros are always the opposite of the little parenthesis linear qualities that we have right here. So if I think of x minus p, the opposite of minus p would be a positive p. So I would have an x-intercept of p comma 0. And if I think about the other one, x minus q, okay, instead of a minus q, we need a positive q. So we'd have q comma 0. Again, this might make a little bit more sense when we go over to an example, but I'm just showing you how it can relate to any number, because you can make p and q any number you want. Again, the axis of symmetry is the x value of the vertex, but notice how we don't really know a vertex in this case. All we know are intercepts. But what's nice is that since symmetry means that things kind of match up, okay, they're kind of mirroring each other, that if we know these 2 points are intercepts, the vertex is directly in between them. Okay, so maybe we'll write that down. The axis of symmetry is in between P and Q. And we'll take a look at an example of this a little bit on, but if these are intercepts, the axis of symmetry is directly in between P and Q. Again, what's nice about this is that the A characteristics that we talked about before still apply here, because notice how A is still the number out front. So let's kind of make sense of this. Here's my intercept form. Okay, I have these 2 little quantities here. Let's focus on those initially. We can say that our intercepts, okay, so let's take a look at our first one. If I have x plus 4, that means I need a minus 4. So I would have negative 4 comma 0. And this one, if it's x minus 2, I need the opposite, which would be a positive 2. So I need 2 comma 0. Hopefully we remember doing this about a month or so ago. Okay, so those are my intercepts. Let's find the axis of symmetry. Okay, now over here, the axis of symmetry is in between P and Q. So if you think about the number in the middle, the exact middle of negative 4 and 2, maybe we'll think about a number line. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2. All right, so right now, I know I have an x-intercept right here, and I have another one right here, but my axis of symmetry is somewhere directly in the middle of those. You can think about this as one of your eyes, and this one is the other eye. We want to find the nose, what's directly in the middle of those. So if I just kind of count in, maybe I'll go 1 tick here, 1 tick there, 1 tick there, 1 tick there, 1 tick there, and another one there. They both meet in the middle somewhere at negative 1. So we can say the axis of symmetry, remember it's an x value, is negative 1. Negative 1 is directly in between negative 4 and 2. Okay, so there's my axis of symmetry. Maybe we'll take a look at the a value. Okay, in this case our a value is negative 1/4. Remember, it's a number directly out front. So according to this, since it's negative, our parabola is going to open down, which means this would be my vertex, and in this case it is a max because it's a high point. Now also, negative or 1/4 itself is smaller than 1, so this time our graph is going to be wide. Okay, remember those same a values we talked about before. Alrighty, so now that we know the 3 different forms of quadratic equations, let's talk about graphing these equations when they look like these 3 different ways. So the first one we're going to talk about is standard form. Remember, that's the one that looks like ax squared plus bx plus c. Everything's kind of nice and neat in a row right there. The first thing we want to do is find and plot the vertex. Now, if you can remember, maybe look back on what we wrote before, the vertex, in this case, we had a little formula, opposite of b over 2a. So if I take a look at the standard form with a, b's, and c's, and this particular equation that we're going to try to graph, let's try to match up what is a, b, and c. In this case, a would be 2. We would have a b value of negative 8, and a c value of 6. Okay, the number in front of the x squared, the number in front of the x, and the number just all by itself. So let's kind of fill in those missing pieces. We need the opposite of b. Now, in this case, if b is negative 8, I want the opposite of that. So the opposite of negative 8 would be positive 8. Now on the bottom, I need 2 times a, but we labeled a as 2, so 2 times 2 can give me 4. 8 over 4 can give me an x value of 2. All right, so we found the x value of the vertex, but what we can do is use this x value to help us find a y value, because if I want to plot the vertex somewhere on a graph, I need to know an x and a y value. So let's take this number 2 that we found and maybe plug it in for our x's and see what our y value is. All right, so 2 times, I'm going to plug in 2 for all of these x's. It looks something like that. And let's figure this out. 2 squared is 4, and if I multiply that by 2, I get 8. Negative 8 times 2 is negative 16, and I have the plus 6 on the end. 8 minus 16 plus 6 gives me negative 2. All right, so I have an x value of 2 and a y value of negative 2. All right, so there's my ordered pair, x comma y. Let's plot that somewhere on our graph. 2, negative 2, somewhere right there. And maybe let's label this as v. Okay, so we know that's our vertex. All right, so we did step number 1. Let's plot the y-intercept. Okay, so we already used a and b. Okay, we already used the 2 and the negative 8. If you can remember back to the beginning, maybe you got to check. The y-intercept was the c value, the one we really haven't used yet. Okay, so maybe we'll say the c value was 6. Let's plot this. If it's a y-intercept, we want to plot it on the y-axis. So let's go to number 6. 1, 2, 3, 4, 5, 6. Somewhere right there. All right. I don't think that's too bad so far. This is when it might get a little tricky. We want to use symmetry to plot the symmetric, maybe you want to think about it as the mirror point. All right, so remember, this vertex, okay, the axis of symmetry goes right through it. And it's a vertical line, so maybe we'll draw a little dotted line right there. Now, the y-intercept that we plotted before, if you notice, is 2 spaces, okay, 1, 2, 2 spaces away from the line of symmetry, which means if it's 2 spaces away to the left, the mirror point would be 2 spaces away to the right. Almost like this was you, okay, and this dotted line is the mirror, your reflection would be this other dot behind the mirror. So we're using symmetry. We're counting. We notice that this y-intercept is 2 spaces away from our dotted line, which means the mirror or symmetric point would have to be 2 spaces away in the other direction. Okay, so that's using symmetry. Now, since we kind of have a general shape of what our parabola looks like, let's actually draw it. So we're going to connect all these dots, trying to make a U shape, because that's what a quadratic graph looks like. All right, so there's graphing when it's in standard form. Remember, that's the ax squared plus bx plus c. All right, let's go into vertex form. This was our second of those 3 different ways that we can see quadratic equations. Remember, vertex form, we still have the same a going on as before, but this time we have h's and k's. And since it's called vertex form, we should be able to automatically find the vertex within our equation. So that's actually what we're going to do first. We're going to find and plot the vertex. Now, if we take a look at the general form right here, we have x minus h. Now, the vertex, if you can remember, was h comma k. So we got to figure out what is h, what is k. Now, in the general form, x minus h is what shows up. But notice how in our problem we have x plus 3. Okay, the minus signs and the plus sign don't really match up. But what we can do here is, remember thinking about those zeros, okay, those little x-intercepts that we talked about? We can do that here. If this is x plus 3, then that means I need a minus 3 once I change it or once I switch it. So if you think about it, if I did x minus h, if I took x minus this negative 3, subtracting a negative actually makes it this positive that's in our problem. So always think about those zeros. Okay, if you have a plus 3, you need a minus 3 in this case. If we go to the k part, the plus k, we notice over here we have a plus 4. So the k in this case would be 4. So we found our vertex h comma k. We have negative 3 comma 4. And we can plot that. 1, 2, 3, 1, 2, 3, 4, somewhere right there. And just like the last one, maybe we'll label it V because we know that's our vertex. Our axis of symmetry should go directly through that. And why don't we just do that right now? Let's draw our axis of symmetry right through the vertex. Alrighty. Let's go into step 2. Pick an x value, find the y value, and plot the point. This is when it gets a little bit different from the one before. Okay, if we go back to standard form, our second step right here was to plot the y-intercept, and that was kind of nice because we knew that that value was c. But notice how in this case we don't have a c value. We have an h and a k, which is our vertex, and the a value is just telling us, does it open up, does it open down, is it narrow, is it wide? We don't have a c value that tells us if it's an y-intercept or not. So this is when you get to be creative and you can pick any x value you want. Okay, anything. Pick something easy though. Maybe I'll pick 1 just because I think that's kind of easy. And let's plug in 1. So my y, or remember f of x, y mean the same thing. I can have negative 1/2 times the 1 that I'm plugging in. And everything else is just going to stay the same. Alright, so let's think about this. We have negative 1/2, and 1 plus 3 changes to a 4 squared plus 4. Let's keep going. Alright, 4 squared is 16, but if I multiply that by negative 1/2, okay, half of 16 is 8, but since it's negative, I'd get negative 8, and I still have that plus 4. Negative 8 plus 4 gives me negative 4. So the point I picked when x was 1 actually ended up being a negative 4. Alright, so let's plot that point. We can go 1, 1, 2, 3, negative 4, somewhere right there. Okay, so there's the point I picked. And step 3, just like we kind of did before, was we're going to use symmetry to help us out. So again, this is the point we know. This is our mirror, kind of our barrier. We want to find the point that would match up with this one if we were to fold it. So notice how this point is 1, 2, 3, 4 units, okay, 4 tick marks away from our axis of symmetry. I want to go 4 tick marks in the other direction. So 1, 2, 3, 4, somewhere right there. Oh, where'd my pen go? Somewhere right there. Alright, and notice how if I were to maybe fold my graph along this dotted line right here, the point I originally plotted would kind of match up or land on top of this other one. Okay, we would say that's the mirror point. So now that we kind of have this guiding direction, we have some points, let's connect them in this U-shaped parabola graph. Hopefully yours looks a little bit smoother than mine, but that's the best I can do right now. And last but not least, we're going to talk about intercept form, the third of the 3 ways we can see these quadratic functions. This one was the weird one with p's and q's, okay, but remember we still have that same a out front. Okay, this is telling us, does it open up, does it open down, is it wide, is it narrow, what's going on? Alright, so since it's called intercept form, maybe the first thing we want to do is actually find the intercepts. So if I have an x plus 2, that means I need a minus 2 as my intercept. And if I have an x minus 4, that means I need to have a positive 4 as my intercept. Remember, it's just the opposite of that sign you see in there. So if these are x-intercepts, let's plot those. We can do negative 2 and 1, 2, 3. We can do 4. There we go. All right, step number 2, we're going to find and plot the vertex. All right, so notice how that kind of, if I go back before, notice how our intercepts kind of look like these 2 points, these 2 symmetric points that we did before, but instead of being down here, okay, our intercepts happen to be on the x-axis. So if these are our mirror points, we know that the vertex has to be directly in the middle of them. Notice how our vertex in this case was directly in the middle of these 2 symmetric points. So that's what we're going to do here. We're going to kind of do this little tick mark counting thing to try and figure out where is our vertex. So I want to find the direct middle of these 2. There's one hop, there's another, there's another, there's another. there's another, there's another. Kind of looks like the middle was right here. So maybe I'll draw my axis of symmetry, okay, right down the middle. And that x value happens to be, it looks like 1. So I know the x value of my vertex is 1. So I know I can plot a dot somewhere on this dotted line, but I'm not exactly sure where it is. It could be somewhere up here, might be somewhere down here, but if I know an x value, we can plug it back in to find the y value. So let's do that. We have y equals negative. If I plug in 1 for all my x's, we can have 1 plus 2, and then 1 minus 4. That would give us, what is this, 3 times negative 3. So negative times 3 would give me negative 3. But I got to multiply that by another negative 3, which would give me 9. So my actual vertex point is 1, 9. We found the 1 from counting to the middle, and when we plugged in that 1, we got 9. So let's plot that point. We have 1, 9, 1, 2, 3, 4, 5, 6, 7, a little bit off our graph. Maybe we'll guess right there, and we'll put a little V for that by our vertex. So last but not least, let's draw our parabola. Okay, we have our different points guiding us. Okay, we're going to try to make the best U shape we can. Hopefully yours looks a little bit better than mine, but what can you do? Okay, doing the best I can. Awesome. Alright, so here's the deal. This video is getting a little bit longer than what I wanted. We're going to save this very, very last part as a part 2 video. So you guys are done for now. Okay, graphing quadratics, hopefully it's going great. We'll spend a little bit more time next class actually graphing some of these, and then we'll come back and watch how we can kind of transform, I guess, these different intercept and vertex form equations into standard form, the ax squared plus bx plus c. So we'll do that next video. Just focus on graphing for now, and we'll come back to this part 2. Okay, I'll see you next time.